Thank you for joining us on American Medicine Today. I'm Kimberly Brummel, joined by Ethan Euchre.
Happy to be here.
Jeff Wagstaff.
Thank you for having me, Kimberly.
Absolutely. And world-renowned orthopedic surgeon, Dr. Alfred Bonatti.
Hello.
Cancer continues to be one of mankind's deadliest killers. And joining us right now is Dr. Sakhrat Khizroev, an electrical engineer and physicist who is working on a cancer treatment using nanotechnology. Thank you for joining us.
Thank you.
Now, this is a pretty complex, complicated topic, but you have said, I read an article, that the scientific community is finally realizing that the way we treat cancer is not optimal. So tell us what you mean by that before we get into the science.
Traditionally, cancer has been treated, surgery, then they applied chemotherapy, radiotherapy. Usually they rely on certain antibody matching to find the cancer cells in the body, and the traditional approaches, because of it, are they lack specificity. So it means therapy kills cancer cells and also kills normal cells. That's a big problem. Mm-hmm. That's why chemotherapy is limited. It works first time, second time, but after that it doesn't really work much. And chemotherapy cannot be used very efficiently because of the collateral damage. Healthy normal cells surrounding cancer tumor sites also are killed. The approach we're using right now, eventually it will happen for sure. It's a more fundamental. We try to distinguish cancer cells from all the normal cells by the electric properties at the molecular level. So we're going deeper in understanding how cancer is different from normal cells. That's a future approach. Eventually it will happen, and we some of the, I would say, pioneers in this field.
Doctor, a very layman question.
Yes.
I read in the research that we've been treating cancer the same way for 20, 30 years. As I sit here talking to you, I have my phone in front of me. And while we were talking, I couldn't help but think, 25 years ago, this phone would have been in a briefcase that you carried around. It was very expensive, and very few people had access to it.
The size of a brick.
Yeah. Today, my phone is more powerful than the computer that Bill Clinton used when he was the president of the United States. How could we have that kind of technology advancements, yet still treat something this complex, it's so prevalent in so many people's lives, the same way we did 25 years ago? It just doesn't make sense.
But you cannot compare the field of medicine to the field of electronics, consumer electronics. In fact, I joined medical world about 7 years ago. Before that, I worked in the computer industry. That's a very interesting question you just asked. And the way computers have been developed, every second year they multiply areal densities, data rates, and so on. There is no problem with making errors. I'm sure you heard of beta versions. There are always first versions which malfunction in most cases. With treatment of humans, you cannot do that. You have to that's a big key difference. You have to develop therapy which functions the first time you apply it. Ideally, that's what you want. You cannot really risk lives of people like you risk with developing computers, cell phones. There are 10 generations of devices which don't work before eventually they come up with something that works. With treating humans, of course, you cannot do that. As a result, we have millions of different protocols to follow. That slows things down.
Sure.
And I'll give you one example of very successful therapy called immunotherapy, cancer therapy. I'm sure you've heard of it.
Yes.
We've spoken to people.
It's been developed at least a decade ago. The concept came up. Maybe 2 decades ago the concept was first born, but it took quite a few years for the concept to be implemented because of many tests need to be done and so on. You have to follow protocol. That's the cost of being careful.
Now, doctor, it's a very complex topic of what you do with your nanotechnology, and we're going to be up against the break in just a couple of minutes. So if you can, break down for us what your research is and how it works.
The way we treat cancer today relies on biology. Biology is a very important field. So what it implies, but biology, it's a very important fundamental field, but it's not sufficient to really treat cancer. Besides biology, There are other fields which are very important. Chemistry, physics. Traditionally, these two fields, especially physics and chemistry, have been somehow neglected in medicine because of the difficult. And the nanoengineering is a field which the idea of nanoengineering, nanotechnology is to efficiently explore physics and chemistry. What it means to understand how cells interact at the molecular, at the atomic level, and to be able to control them, to distinguish cancer cells from normal cells. So that knowledge has not been there. So that's what we're trying to bring in the game right now.
I have to ask, the nanotechnology goes in, it identifies the cancer cells. When you disperse the nanotechnology, what does it do? Does it envelop them and destroy them? How is it actually ridding the cancer cells?
It delivers drugs to those cells.
Straight to them? And
You're absolutely correct. In fact, nanotechnology is more than that. It's a delivery vehicle is one way to do that. It's probably the most popular way today to do it. Another way, more advanced way, next generation nanotechnology, is nanoparticles can be programmed. They're like little machines, you can say. That they're about 30 nanometer in diameter. 30 nanometers is 2,000 times thinner than the average human hair. So they go any way they want to go. But the idea of nanotechnology is to be able to control this nanomachine very precisely. And these machines can, if they can get inside the cancer cells, they themselves can kill cancer cells without even using a drug. That, of course, makes things much easier. The drug is a very important field, but the drug has toxicity. And every time you deal with a drug, with any chemistry, you have collateral damage. Nanotechnology, what it does, pretty much ideally, it eliminates any side effect. It just kills cancer cells and nothing else.
Doctor, how you direct the nanofilament to the cell?
We program of nanoparticles. They're administered intravenously. So they go all over the body, through blood, through lymph, and like little antennas. They can pick up electric fields coming from cancer cells, which are very different from the electric fields coming from normal cells. That's how they know. This is pretty much very, very fundamental signature, you can say, of cancer cells. And when they pick up that information, they go there. Because they are so small, they can catch the cancer, you can say, at a single cell level. That's what we're aiming for, of course.
Okay, you're talking about animal studies now. How long before human trials?
Animal studies we've finished on mice. Now we're working together with many hospitals and cancer centers, including Moffitt Cancer Institute in Tampa. First animal studies were done on ovarian cancer. And now with other cancer research groups, we're working on different cancers, prostate cancer, pancreatic cancer, breast cancer, and others, also doing on different species, on different animals. We expect within 2 years we can get to human preclinical trials.
Okay, thank you so much. Unfortunately, we're out of time. Dr. Sakhrat Khizroev, an electrical engineer and physicist who is working on a cancer treatment using nanotechnology. Thank you so much for your innovative work.
Very interesting
research.
stuff,
Yes.
Doctor. Thank you.
Thank you.
Have a good one.
Thank
Bye-bye.
you.
And it's even cooler that there's
Yes.
Moffitt
It's
right
right
here in
here.
our backyard. I didn't even know that when I set up this interview.
It's almost sci-fi.
Moffitt, we're calling you next.
Very cool.